Good afternoon to everyone. So today we'll just discuss about mathematical symbol. That is one. It is given as mentioned in the sessions. So basic requirement for mathematical symbol is two package. One is LaTeX sim, and or we can use AMS sim. So these are the two packages that we require to create mathematical symbols. In addition, we'll need AMS math, AMS theorem packages, which are necessary for creating mathematical expressions. So mathematical symbols can be classified as, first we use alpha, beta, gamma like this. Those are called Greek letters. And then binary operations like multiplication, union, intersection, then addition, all this. Then there is some relationship symbols we will see, that is less than, equal to, or equal to, less than, greater than, like that. Then arrow symbol we'll see. Then variables size symbol like integration, summation, product, like this. And some LaTeX mathematical expression construction we'll see. So some of these expressions we'll see like this. This is how we can create cases in an expression, and this is a simple summation. Here we will see some symbol, then integration we will see, and then this is the product symbol, and then we'll see matrix and determinant. Of course, we'll see vector product, how to write a vector, and how to write this trigonometric function. Here simple, I have written Laplace transform cos at. Then we'll see limit, and then we'll go for some complicated expressions like this. Of course, there are two more sessions on this mathematical symbols, so more complicated expressions will be coming in next two sessions. Of course, that will be discussed by some other resource persons. So we'll go to now Text Studio, and we'll see how to create mathematical symbols. So let me see. First, I will open Text Studio. So first, let us create. In fact, I will copy these things, document, class, and all this. Say we'll use this because we have been using regularly these things. So here we have used two packages, AMS sim and LaTeX sim, which are necessary for creating mathematical symbols. Of course, we'll need AMS math for mathematical expression. Also, additionally, we have used AMS theorem, THM. So even if this is not there, it will work. Now from here, let us go to.
It's not visible.
Yes, yeah.
Not visible.
Is it
Black.
not visible?
Yeah, totally black. Yeah.
Is it visible now, ma'am?
No. It's not sharing, but stop sharing.
1 minute, ma'am. I will again share it.
Okay.
Now it is visible.
Yeah.
Okay. So I have just copied it from my previous document. So document class, these things are there. Only thing is that I have used these packages. These first two are for creating symbols in mathematical symbols, and of course for mathematical expression we need AMS math. So these are the packages we'll be using. Then we'll simply go to begin document. and it will come out. So first we'll see Greek symbols or letters. So I will simply write Greek letters. Now all mathematical symbols should be written in between the dollars. So if we write simply say alpha and compile it, there will be an error. Here it is coming missing dollar inserted. That means we have to insert this alpha command between the dollars. So like this, alpha. So it has come like this, alpha. This is alpha. Similarly, we can write beta, gamma also. We have also earlier also we have seen this gamma. So these are alpha, beta, gamma, but there are more symbols, right? Like for gamma. So if we use capital G in place of small g, say capital G gamma, so it will be this. Sorry. So it is gamma. So it has come like this. This is the gamma. So this similarly we can see delta. There are two delta. First one is this one, delta. So this delta has come, but if we use capital B, then it will be operator that we use like this one, delta. So there is a very long list of these Greek symbols or letters. So I will be sharing the entire text or a PDF of all the Greek symbols that we can use in LaTeX. Now say pi. So for pi we will simply write \pi, small pi. So it will come like this. This is pi. So we can also have big pi also like this, capital Pi. This one. In fact, we use this for product also. But for product also there is one another symbol we can see, \prod, product. So it comes like this, almost same, both are. So this is how, similarly there are more symbols like omega, there omega, then lambda, like this. These are Greek letters. So this is lambda. Then we also have capital L also, LAMBDA. So first one is small l, and for second one it is capital L. So like this we will have many Greek symbols, phi, psi, sigma, then epsilon, like this. So this is how we will be using Greek symbols. Then next we'll see that is binary operation symbols. Binary operation symbols. So binary operation symbols say time, multiplication. For multiplication, we say times, T-I-M-E-S, times. So if we use this, so it comes like this, multiplication. For division, we can use \div. So symbol will be this one, division. Then we have union if we go to algebra, we'll have union. For union, we'll use, so this will be in between dollar slash cup. If we use cup, it will come like this. This is the union. And for intersection, we'll simply use cap. It will come like this. This is first one is union, second one is intersection. So for union, we use cup, backslash cup, and for intersection, we use backslash cap. Now there are some ring sum operation also we'll use in graph, say in direct product of spaces, subspaces, and as well as in graph theory. So we'll simply write O plus like this. If we write O plus, so it will be direct sum or ring sum operator like this. It will come. So there are many others operators, say subset. If we want subset, we'll simply write slash subset. So let us, so it is come like this, subset. Now if we take it other way, say if I replace sub by B by P, that is superset, or like this, B by P, so it will be simply reversed like this, superset. So subset, and here it is subset. So these are some of the binary operations. So of course there are additional symbols, like we can use star if we need. Then there are dot. Sometimes for multiplication we'll use dot. So dot should be in, not in the line, it should be in the center. So we'll simply write backslash C dot, center dot. Dot would be in the center of the line like this. This is in the center of the line. Suppose we can write like this. I will simply write A C dot B. That should be a gap after this comma command. So it will come like this, A dot B. If we remove this and simply put a dot here, simply put a dot here, it will come down. So this is not multiplication actually. So it should be always C dot. It should be always C dot. So there are additional symbols we can use. Suppose I want to use plus and minus, then it will be simply, first plus will appear and below plus it will be minus. So PS, plus minus. So it will come like this. There is some error, I think, plus minus. Sorry, S I have written, it should be minus M, PN. So this is plus minus. But if I reverse M and P, suppose I reverse slash MP, then after compilation we'll get minus plus. Minus will appear above the plus. So these are some of the binary operations. There are many more like this which we can use in LaTeX. So by practicing only we can remember these symbol commands for different binary operation symbols. Then there are some relationship symbols. Let us go for relationship symbols. Relationship symbols. Of course, less than and greater than, it will easily come. But what about less than equal to? Slash So we'll use, sorry, backslash. For less than equal to, we'll write LE. So it will be less than equal to. But if we want not less than equal to, it is not greater than equal to, I want not less than equal to. So backslash and LE. Let's see. So it is not taking. I think command is different. 1 minute. Say I will not less than equal to is not there. I think it is not equal to is there. Any. So it is not equal to it. Right. N is stand for this negative, not equal to. Then similarly we will have greater than equal to, like this, greater than equal to. So we can use, these are some relationships, symbols. And of course epsilon in, suppose we write a is an element in the set S, /in capital S. So we'll get A is an element in the set S. We can write it other way also. We can write S ni any A. Now we can also write it other way. A is contained in S, like this. So there are some more symbols for parallel lines. If we write this, say line, we can write, say line A is parallel to B. So we can write mathematically simply parallel, and write parallel to B. We can write like this. So here we get line A is parallel to B. So this is how we can use relationship symbols. So equivalence relationships also we can use. For equivalence, suppose I want to write this, A is equivalent to B modulo N. So I will write A equiv. We use this command, EQUIV, equiv B. For modulo, we'll use the command \p mod M. So A is equivalent to B modulo M. So if we compile this, let us see how it comes. It comes like this. This bracket, it has taken bracket modulo M itself. This bracket has come automatically. Then there are more symbols, subset, superset also we can write like this. So next we can go for some arrows. Arrow, we can write arrow symbol. So, ARROW, arrow, sorry, it should be arrow symbol. Say arrow symbol. So in mathematics we use different types of arrows. So first one, say arrow should direct in the right hand side direction. So I will write simply right arrow. So it will go as this one, right arrow. Now if I make this R capital, what we will get? Let us see. Slash capital R I G H T, right? ARROW. Say. So now it has taken two lines, which we generally use as implies sign. Now if I want longer arrow, so I will simply add long here. Say I will write \long right arrow. So if I compile, I think this is it. Long should be, I think, capital. Long right arrow. Now its length has increased. Compare these two. The length has increased. So long gives increases the length of the arrow. So similarly, we have implies and implied by symbol. So we can write slash left right arrow. Left right arrow. So this has come as single line. So to bring it to double arrow, so I will make this one as L, capital L. So it will come like this. Implies and implied by symbols. So these are some of the basic arrow symbols. In fact, there are more symbols related to the arrows. Then I will go to some mathematical symbols. Say, suppose I want to write some, I will write, it is called variable sized symbol. That is symbols those which involves some variables like summation. So I will write backslash sum. So this is, it will come like this. Now for product we can write like this, say PROD, product. You can write like this. Then for integration, we'll simply use the command /int. It is integration. These are the commands: sum, product, then integration. In fact, there is another symbol for line integral. We can write /OINT. You can write like this. It comes like this. Integral. Then, of course, there are some cases we use intersection union. So if we want them in bigger size, so we can write big cap, and similarly we can write /big cup. So size will be bigger if we compile this. So its size will be bigger. So these are some of the variable size symbols that we'll use in mathematics. Now, after this, of course, for trigonometric symbol is there. For trigonometric section, we can write some functions. Say, suppose I want to write cos theta. One can write directly, say, cos / theta. In that case, what we'll do? We'll simply write / cos and then theta. Now in this case, it comes like this. So second one looks better. So here we have used the command / cos. Similarly, we can use arc. We can use arc sine, say arc sine. I will write theta. So it will come like this. Then, so these are some trigonometric function. We write like this: arc / cos / sine. So this is how we use. Press theta. So it will come like this. Now after this, I want to write some expressions. So let us say fraction. Let's talk about fraction. How to write fraction. Fraction. So for fractions, so let us make a simple sentence. The probability is say I will write in math mod / frac. We'll use two brackets here like this. First one will be numerator, second one will be denominator. So I will write 2/5. Now if I compile here, now this size of this 2/5 is smaller. 5 of 2/5 appears to be smaller because this expression is not in display math mode. So for display math mode, in fraction we use one additional. I will write in another command. I will write slash, then only we can able to compare 2 and say 5. I will write here dfrac, display fraction. It is dfrac. So now we'll compile. Then we can easily see the difference in the size. So the second expression, this one, is in display math form, whereas the first one is in line form. So while writing a fraction along with a sentence, we generally use dfrac command. So this is something related to the fractions. So now we would like to go for some expressions, some mathematical expressions. So we will write to some mathematical expressions. So first, let us write an integral. How to write an integral? Say, if I take it in double dollar form, so it will come as display form. If I write the expression in between single dollars, it will be a line format form. So for display form, I will use double dollar. So suppose I want some integration is there. I is equal to slash say int. Now it is a definite integral, say it extends from, now for lower limit we use underscore like this. I will show the above. So suppose I want xa, so I will write x underscore a. Okay, this is incomplete, so it is showing some error. So I will write like this. Now say this has come as x suffix a. So for suffix we'll write underscore, and for exponents we will use cap. Suppose I will write x cap a, then we'll get x to the power a. So these are basics. So now I want to complete this integral. So let us remove first this percentage sign. Now underscore, I will write, say, it is always write the parameter in between the brackets, parentheses. So I will write, say, 0. And now this underscore is only for this 0. After this, I will use a cap. It will go, cap is, say, I will write some infinity, say. slash infinity will write as backslash infpy infinity. Then here I will write an expression. Let us see if it is complete. So far we have created this expression, I equal to 0 to infinity. Now let us put an expression. So we'll do e to the power, I will write, now this expression will be written between the parentheses. So I will write -1 by x squared and dx. I will write later on. So now this has come like this, e to the power -1 by x squared, then dx I will write here, dx. It will come like this. Now in some expression we need to define, some cases also. The another important thing, we can replace this $$ by a command called \begin. I will use display. It has come here, display math. I will just enter here. Now it has come together. If something begins, it ends also. So I will take this expression from here, copy, cut, and then put it here. And then compile. Then we'll get the same expression. It is display math. Instead of $, we can use this one, display math. Now let us go for cases. How to create cases? Suppose we have a function, we can write like this, begin display math. Now I will write fx equal to, now there will be two cases, say x is equal to 1 if x is rational and it is -1 if x is irrational. So for this we can write \begin cases. So begin cases. So let us, you can write first one, say 1, comma, I will write text. We'll see the result. 4 x. Say x is, say I will write greater than 0. Say x is greater than 0. Then I will break this line. Then I will write -1. I will again write text. 4 I will write x, say greater than, I will write this, I will write LE less than equal to, I will write slash, say I will use this one, greater than 0. Now since this cases has begun, so I must end it, and cases. When will be matrix is coming. So let us try to see this, what is going on. I think something I have missed out, I think. Some bracket I have missed out. So begin cases, end cases. I think this one extra bracket it is saying. If I write like this, I will remove this one. And -1, I will write, if I like this, 4, So it is, where is that? Okay, it is coming like this. It is coming like this. Now this 4 is attached to x, and also they are not aligned. So for aligning this, we can write AND here. This AND command will give. So we also need a distance. So I will write simply quad. We create a space quad, and also we'll give one quad here, so it will look good. So here also we can give one quad. So now it has come like this. Expression is this one: fx equal to 1 for x less than equal to 0, and it is -1 for x greater than 0. So in this way we can define cases. We can increase this one also. We can have more cases below. So here I have shown only 2. Now let us go for a summation expression. So again, say begin this display math. So I want to write a expression with summation. So I will write simply f a comma b, say, is equal to sum. So summation will come. Now here it is coming. So it says minimum value in the sum and the maximum. So one can write like this. So minimum I can write, say, n equal to, say, -/infinity. And maximum I will write slash, say, inft, infinity. So let us see what it has come. It has come like this: f of a b is equal to n is -infinity to infinity. Now the expression function will be written here. Say I will write a to the power. Now all expression exponents would come in the parentheses. I can write n plus 1 by 2, and similarly I can say write b to the power n, then bracket, we can write n minus 1, say, by 2. We can write like this. So the expression turns out to be like this: f of ab is sum of this, where ab. So likewise we can use this summation symbol. So vector also we can create. Let us see how to create vector. So we can write begin, say, display math. Suppose f we can write as, we want to write a dot b cross c, vector a dot vector b cross c. So I will write, for vector I will simply use the command vec, and within the parenthesis I will write a. Then dot means multiplication, scalar product, so I will use c dot, then bracket, I will write vec b times x plus vec c. Now here I have one argument, so even if I don't use the parentheses like this, it will take. But it is always better to write the arguments within the parentheses. So I am writing this one, I will leave c without parentheses. So let us compile and see. So it will come like this: vector a dot b cross c. So this is how we use write vector. Now we can also create matrix also. For matrix we will use array. So again, say begin display math, and use display math. Now matrix name I will give a is equal to, now there will be square bracket, so I will write slash left, and I will put this bracket, square bracket. At the same time, I will take right, so it has taken automatically. Now there will be say 3 by 3 matrix. So I will simply write begin array, and there will in 3 by 3 matrix there will be 3 columns. It is somewhat like creating a table. So 3 columns, C, C, C. Row we can write accordingly. So there will be 3 columns. So first one I am writing say A and B, say B and C. Then I will break this line. Then I can write say A square and then B square and say C square. And now for square root, say I want to use square. For square root, we simply use the command sqrt. And within the parenthesis, I will simply write A. Now second one is say cube root. So I can write sqrt. Now cube, I have to put a square bracket. So here it will be 3 and it will be E. And say third one, say I want to write fifth root. So I will say again write sqrt 5C. Now when this array has begun, I must end the array. End array. I must end the array. Now let us combine. So what we'll get? So this is the matrix we have created. So the last line is important. So to get cube root, we are adding one square bracket here. Here we are writing 3 and this is B. B is in parenthesis, curved bracket, and 3 is in square bracket. So this is how we create a matrix. In fact, if we want to write this as a determinant, we just remove this square bracket by line, vertical line. This one, and similarly at the end, this will write as a vertical line. So let us see. So this came as a determinant. So using array, we can write matrices and determinants. Okay, then there are some other expressions. Say let us see product expression. Slash say begin display math. Say I will write slash phi n. Euler function say phi n is equal to, I will write product, prod, product. Now it has come here already. So we'll just enter. I will write, okay, I don't want the maximum value. So I will simply remove this part and I will write P divides N. And here, so what we got, we can see like this. We have got this expression. Phi N, P divides N. So if I add one N here, so I will get this one. N phi P. And so here I will get, now this bracket should be bigger. So simply I start with this one. I will write 1 minus, then fraction. So it is 1 and 1 by P. So numerator is 1, denominator is P. So let us see this one. Now see, this 1 has gone out of the bracket. So to cover this, we'll just write left, use the command left, and here we'll use the command right. So it will now it looks better. This 1 by p is also covered. So this is how we use the product symbol. In fact, we can write it different way also. We can use minimum and maximum as we have used in case of sum here. Maximum and minimum. Now there are some more complicated expressions also. See, we can go for those also. Is say one product as well as sum. So we can write begin display math. So I can define say fx. I can write say fx is equal to slash sum. Say some expression. Say I only use the say I say greater than equal to j. I will write x underscore I j and say product. I can put this one into a product also. So this product is inside here. Say yes, CROD underscore. Say I will write say k. I will write x square. This should be say I is equal to say I greater than equal to say what will write I will write ai greater than equal to say 0. I will write x so or a underscore ij say x to the power a say x to the power I. So let us see what type of expression we have got. We have got an expression of this type. So I want this product to be inside bracket. So I will simply write slash left. Now I want to put this with curly bracket. Now when we write curly bracket, we'll use backslash curly. Now this backslash is used only in case of this curly bracket. So we'll have this one. Okay, backslash this, and I will put it here. And now let us see. Something is missing. It should be slash right is missing because I have used slash left. So slash right will come. So we'll get expression of this type. So this is how we created some mathematical expressions. There are more complicated expressions we can create it. Now for say I want to create a partial differential equation. Let's say I will write display begin says let's begin display math. So I want to create a partial differential equation. Now for partial differential equation, I will let us write a fraction. First fraction. Now partial command is like this backslash PARTIAL. We'll exactly write partial. Partial square z. Say one variable is then slash partial x square plus again we'll write say frac slash partial square z. I will write slash partial I square say equal to 0. So let us combine how it looks. So we'll get a partial differential equation of this type. So generally we call it del, but del is a different. So we use partial for this one. So these are some of the basics regarding creating mathematical symbols. There are many more. I will be sharing the complete sheets PDF file of symbols to Dr. Manas Bara, and he will share to others. So this is what I want to show, how we can create mathematical symbols and expressions using LaTeX. Okay. Thank you, sir. Hello.
Thank you.
Thank
Thank you, Nipen.
Thank you, ma'am.
That's hello, participants. I think this is very beneficial for you for creating the question paper. So, if any question, please put in the chat box. Let's see. No, there is no question. I think.
Yes.
Hello. Hello.
Jiten, there is a question.
Yes, I have it. Yes, it's there.
Yes, sir.
Sir, how to write a 1 by modulus sine square root of greatest integer function?
1 by
1 by modulus. No. Yes, 1 by modulus sine.
Yes.
Square root of greatest integer function.
Okay, we'll need to take the fraction. So I am creating. So we'll go to frac. So 1 by modulus.
Yes, sir.
You can write slash left and a vertical line, then slash right, another vertical line. So in between, we'll write sine, backslash sine, then square root, backslash sqrt, square root. Inside square root, it is greatest integer function.
Yes, sir.
X. So we can write this one as, we put curly bracket, then so we can write this x. Let us combine if it is coming like this.
There are two, right?
Yes,
Okay.
sir.
Yes. There are two, right? I think that is the error.
Thank you, sir.
Okay, it will come. It is coming like this.
Yes, sir. Okay, thank you, sir.
Okay, welcome.
Thank you. Thank you, Dr. Nipen Saikia.
Welcome, ma'am.
And this session is over. And next day we will meet again at 11 a.m. Thank you.